Hello, my name is Abel Martinez, and I'm with Team 38. The team consists of Alexis Dixon, Samuel Tariq, Samuel Woods, and we are the Smart Ball Fetch team. Our project was to design and make a smart ball. A smart ball would be an autonomous toy which moved in a pseudorandom algorithm to entertain a young pet. With the stress of buying and raising a new young pet, this would leave you more time to do other tasks as the young pet would be entertained by itself.
This slide shows a revamped version of our system subsystem breakdown. So Abel is taking care of our dog collar, and he is also doing the data transmission between the dog collar and the ball, as is Alexis. Alexis is also working on the structural integrity of the ball as well as any of our other 3D printing needs, and she's working on the sensors. Within the ball, Sam is working on the MCU, and I'm working on the power system and the motor system. This is the first of two slides on my power and motor subsystem. On the slide, you can see a block diagram that shows you the power flow between the wireless transmitter all the way to the motors that eventually move the ball. Some of the key decisions that affected my subsystem was the use of wireless charging, the use of the H-bridge that was on the TI MCU rather than an external H-bridge, and testing the motors to find similar RPMs. This slide showcases some of the major data from my powered motor subsystem. The first picture shows a code demo written for a Arduino that was to be translated to program the TI MCU for one of the specific cases that the ball would be moving. The next piece of data on the top right is a graph comparing the RPMs of 6 different DC motors. And on the bottom, the two tables I have show the wireless charging validation between different mediums.
The key decisions for the MCU subsystem were to use BLE RSSI values as a basis for distance. We ended up using Code Composer Studio Cloud for programming and flashing instead of the desktop version. We implemented a random number generator to generate a random number, modulate it, and use that value for different motor movements. And we decided that the ball should wait in a low power mode until a signal is received from the collar, then it would start activating. The block diagram on the right shows the high-level operations. On the right, we have the data for an RSSI test trial where we measured the RSSI values from the MCU at varying distances in feet. We averaged these values to use as a test case for the distance estimation algorithm. We also measured the RSSI values at 1 feet so we could implement a standard to go by. The left side shows the results of the algorithm using another set of test values and even includes a description of how the motors would move if they became active.
The key decisions I had to make in this project were about the structure of the ball rather than the sensors themselves, because our sponsor wanted us to use a specific board that already had all the sensors we would need on them. And so those decisions consisted of the ball design, which were 2 spheres that screwed together mechanically, and the width of the ball to ensure that it would withstand a dog, and the internal design. On the right-hand side of the screen, you can see that the MCU of the ball initiates connection to the MCU of the collar, and the collar in turn sends RSSI values back to the ball, which helps us determine the distance between the ball and the dog. On the bottom of the screen, you can see renderings of the internal structure in the ball on the left-hand side and the wireless charging base on the right-hand side. On the left-hand side of the screen, you can see data we collected last semester that shows a correlation between RSSI values and the distance between the two MCUs. On the right-hand side, you can see a GIF that has the validation that I have done from this semester to test the strength of the 3D printed balls.
So my subsystem was the dog collar subsystem. So I had a lot of changes with this. I had to change the entire MCU to a smaller, more compact one that would fit better on a dog collar. With this new MCU, I was able to solder on a coin cell battery holder to the back of it so that it could run on its own power. I was also able to change the advertising code so that it ran more power efficiently. I was also able to program both MCUs to connect automatically to one another when they were both turned on. I was able to program it this way because I was able to find the BLE MAC address from the one advertising and put it into the scanning code so that it only scanned for that specific MAC address. After finding the MAC address, the one scanning would get the RSSI values from the one advertising the signal. The new MCU did mean we'd have to use new data for the algorithm though. The new data had a similar trend but had higher values at the farther way it got.
Some of our changes in execution included using wireless charging, and that resulted in us making a model wireless charging base to secure a good connection. We also had trouble contacting our sponsor throughout the semester, which caused delays in the programming of the TI MCU, which also had limited resources online. So as a plan B and C, we wanted to use either an Arduino or an older TI MCU that was more well documented instead of the newer one. Along with the removal of the external H bridge when our sponsor asked us to use that specific component on the TI MCU. And the color board was changed to a more compact one to decrease the size of the collar, and it also provided a better accelerometer and more precise RSSI values.
For a brief overview of the system validation summary, we were behind our schedule for most of the semester due to complications with hardware and communications with our sponsor. There was a time where we changed the MCU to a different model and even an Arduino, but we were able to get a hold of our sponsor again and switch back to the original MCU. Unfortunately, once we had a solid plan to continue, the virus situation happened and we couldn't progress any further.
Even though we ran into some problems, we were able to complete some integration. We were able to get a code for scanning and advertising. We were able to integrate the power system with the motors. We were also able to get a model of a smart ball and its internal components. We were able to get the new ranges with the new MCU, and we also had established a successful connection when one board was being turned off and on while the other board was completely on. We were also able to get a base code for the motors to be programmed on the TI MCU.
If we had time to finish our project for the dog collar, we would need to ensure immediate connection once the boards were turned on, test the ranges, and ensure that the ball acts as intended, as well as test for what happens if the ball and collar disconnect for whatever reason. For the structure, we would need to print a full-size ball, internal structure, MCU, collar holder, and wireless charging base. We would then test the ball and internal structure to make sure it rolls properly, order rubber gaskets to test for water resistance, and finally test RSSI values with all encasings.
To continue with the power and motors, we would have to test the motors with the programmed TI MCU, verify that the components and power systems fit and work well inside the ball encasement, test the ball movement in different scenarios, and determine the time it takes to fully charge the smart ball. For the MCU, we would have to test the connections to the collar subsystems to receive the RSSI signals, validate the distance estimation with this raw RSSI data, and test the motor control output with the generated cases.
In conclusion, the coronavirus came at a very unfortunate time as we were finally able to get past a major roadblock from the beginning of the semester, but we did learn a lot from this project. We were able to apply all our previous class knowledge, such as signal processing, to work with TI hardware and software. Unfortunately, we are not going to be able to complete the project, but our sponsor has asked us to leave the project in a state so that if any team were to pick it up in the future, they could finish it with ease. Thank you for your time.